Hey guys, and welcome back to another Kubernetes video. So in our last video we talked about replica sets and deployments and how they're used to group and manage groups of pods. In today's video we're going to discuss how we can actually communicate with those groups of pods without having to directly address individual pods, because as we know, pods are an ephemeral resource, which means that they could be created and destroyed at any point. And along with the pods, their IP addresses could be created and destroyed. So if we have hard-coded pod IP addresses, that's going to cause a problem, because when the pod goes down, it's most likely a new pod will be spun up, and that pod will have a different IP address. So then we will no longer be able to communicate with that. So Kubernetes services address that problem, and let's get into some of the details. So Kubernetes services give us a policy to access pods. So again, just implementing different methods of communication to sets of pods or individual pods. It facilitates internal and external communication. So if we're a party outside of our cluster and we're trying to communicate with an application, let's say inside the cluster, services will allow us to do that. But also, if we are a particular application inside the cluster and we want to communicate with another application, say a front end and a back end of a web service or something like that, then we can do that efficiently with services as well. It provides an abstraction between front ends and individual back end pods. So as I mentioned, we can have within the cluster any group of pods that want to communicate in an abstracted fashion with another group of pods. Services will allow us to provide a point of communication to a whole group of pods. Now, let's have a look at some Kubernetes networking basics in order to understand some of the use cases of services. So pods operate on an internal cluster network. So if you look at our diagram here, we have this 102.10 IP address space for everything within the cluster or within a particular node, and then we have this 192.168 address space for our nodes themselves and user machines that are on the same network. So external machines can't directly access these 102.10 addressed pods and services. However, services provide a solution to that. They'll allow us to provide a method of communication between two different address spaces, between our external node and user machine address spaces and our internal cluster network. Now let's look at a couple of different types of services and how they solve different problems within Kubernetes networking. So first of all, cluster IP is the default Kubernetes service type. It facilitates communication within a cluster. So this provides a solution to our use case of having front end and back end pods of the same application, for example, or communications between different applications all within the same cluster. So it is the default service type, as I mentioned. So let's have a quick look at the YAML and break it down a little bit. So selector defines the pods to which the service will connect. So any pod with this tag here, my app, will be selected for communication via this particular service. Port, this is a port that the service itself communicates on, and target port is a port that the backend pods communicate on. Now let's have a look at that in diagram format and see how it translates out in terms of our actual Kubernetes objects. So let's say we have a front-end replica set, so a set of pods that wants to communicate with our back-end set of pods that are running here. Well, in this case, we can define this service. We'll set our port to be 80, which means that our replica set will address the service at port 80. The service will address the backend pods at port 9376 because that's our target port as we defined within the service. And all of these pods will have this my_app tag. So as we mentioned before, one of the benefits of this is that our front-end replica set will know the IP of the service, but it will not know the IP of the backend pods, which means when eventually a pod does go down and a new pod is provisioned, it may have 102.10.10.4 as its IP address, then our service will simply add that and start communicating with that, and it won't impact our replica set here. Our replica set will still be able to communicate with 3 backend pods, just doing so via the service. NodePort. So NodePort facilitates access to the application via a port on a node. So we can see that the only essential difference here is that we've added this NodePort value of 30,007. So what does that mean? Let's jump into our next diagram slide to illustrate that. So in this case, we're accessing our application from outside of the cluster, from a user machine. What does that mean? That means that we have to communicate on this particular network here, and we don't have direct access to the internal network that's addressed 102.10.x. So what we do is we define this service and we open a port on the node itself, and that allows communication between our external machine and the backend pods via this service once again. Finally, LoadBalancer. So LoadBalancer exposes a service externally using a cloud provider's load balancer. So generally load balancers will only be defined when we're running our Kubernetes cluster on a particular cloud provider like AWS, GCP, or Azure, because they will have inbuilt capabilities to provision load balancers. So again, we have our selector field, we have our port field, we have our target port field. All of these have the same meaning as they did for cluster IP, so we won't go into details on them again. But we've defined the type, in this case, as load balancer instead of NodePort or cluster IP. And one other thing to mention here is that we have this status field. So what this status field is essentially is that when we provision any Kubernetes object, this status field will then be present, and it'll let us know information about how the object is running at the current time. So what we will personally define is as far as type here, and then once the object is deployed, status will automatically be populated when we say use kubectl describe on our particular service or whatever Kubernetes object it is. But the important thing to note is that we have this IP defined here, and that's the IP that has been automatically provisioned by the cloud provider, and the load balancer has been assigned that IP address. So this is how things look from a physical architecture standpoint for the load balancer. So again, the load balancer's use case is for external traffic. The user will access the cloud load balancer via an external IP address, the one that we've mentioned down here. That will then connect to our service via the port that we've defined in the port, and then we'll connect back to our backend pods with the port that we've defined in target port. So that is how services work from a high-end perspective. Hope that was useful, and if you have any questions, please leave a comment. Don't forget to like and subscribe, and I will see you in the next one.